Integration by parts, IBP. The simplest example I can think of for doing integration by parts is to integrate x times e to the x. As with substitution, you could try guessing. And you could even try substitution to begin with, though remember, letting w equal x doesn't help because you get the exact same integral. You could try letting w be this, but then dw would involve the product rule, and that would get kind of complicated. So it seems like substitution is not the way to go. Integration by parts is the way to go. And what you want to do is, in this product of two functions, that is the integrand function, you want to identify one of those factors as what's called u, and another one is what's called v prime, or in some books, dv. How do you decide which one's u and which one's v prime? V prime is the derivative of some function, call it v. The most important thing to realize is v prime has to be something relatively easy to integrate if you're going to find v. That's the most important thing. In this present example, v prime could be x, or it could be e to the x, and both of those are easy to integrate. However, another bit of advice is you want to choose u to be something whose derivative is hopefully simpler. If u were e to the x, then its derivative would be e to the x, which is the same level of simplicity. On the other hand, if u were x, then its derivative would be 1, and that's simpler. So it seems like perhaps this is the way to go based on the advice I gave just a minute ago. Make sure v prime is something easy to integrate so we can find v. V prime is the derivative of v. Make sure u is something that is not only easy to differentiate, but maybe becomes simpler. If v prime is e to the x, the integral of that is e to the x. Do I need a plus c? No, don't bother. You could do a plus c, but it's just not necessary. We are doing an indefinite integral. We are going to add a plus c at the very end. The integration by parts formula says this equals u times v minus the integral of v times u prime with respect to x. That's what the integration by parts formula says. Why does it work? Save that for Monday. We will see when we use integration by parts and we check the answer by differentiation, we will always end up using the product rule. This is related to the product rule for derivatives. So I want to use this formula. When I look at these things here, I think, first of all, about multiplying these two functions, u times v. That's what I do, x times e to the x. Subtract the integral of the product of these two functions. I'm circling them here for emphasis. You don't have to circle them when you do your homework. U times v minus the integral of v times u prime. E to the x times 1. Hey, that's just e to the x. And that's a simpler integral to do. We're almost done. This is the point of integration by parts, is we want to get another integral that's simpler. It is. It looks like this is the answer. Now add your c at the end. But don't forget, this is something you should always do. Check it. Check it by differentiation. Notice we will need the product rule in the first term. We have a left function and a right function. L and R, you can remember the product rule as left d right plus right d left, the d meaning derivative. Left d right, the derivative of e to the x is e to the x. Plus right d left, the derivative of x is 1. That's so far as the derivative of this product. But now we need to subtract the derivative of e to the x, which is e to the x. And then the derivative of c is 0. I'll go ahead and write a 0 there this very first time, but I will not do it anymore. The derivative of c is 0. As if by magic, the e to the x's cancel, and you are left with the original integrand function, x times e to the x. Those two things match. It worked. Check. All right, let's try a harder example. Still involving e, but instead of an x, let's make it an x squared. And let's make the power of e not be just a plain old x, but maybe negative 2x or something. All right, again, listen very carefully. You've got the product of two functions here. That's one hint that maybe integration by parts is useful. Another hint is that if you try substitutions, it doesn't really seem to help. You've got to pick a u, you've got to pick a v prime. Again, the most important thing is that v prime is something easy to integrate. A secondary condition is that u prime is something simpler than u. If v prime is x squared, that's easy to integrate. And if v prime is e to the negative 2x, that's easy to integrate. Either choice is easy to integrate. However, only one of them has a simpler derivative in terms of, well, in this case, being a lower power of x. If I chose u to be e to the negative 2x, then u prime is negative 2e to the negative 2x, which is not really simpler. I mean, you might wonder, does the 2 here make this more complicated? No, it doesn't. I'm saying simpler in terms of being a lower power of x. If u is x squared, v prime better be the other factor, e to the negative 2x. And I need to integrate that to find v. That can be done by guessing. Negative 1/2 e to the negative 2x. You don't need the plus c. Once again, the formula is, I think this is worth writing down every single time you use integration by parts. Just to remind yourself what it is. Try to work at memorizing it. U times v minus the integral of v times u prime. When you compare it with the original function, it's like the role of u and v change. Here, in this thing, this is a u here, and this is a v prime here. But over in this integral, the derivative is on the u, not the v. Kind of weird, but true. Go ahead and compute u times v first. In this case, I have a minus sign, a minus 1/2 x squared e to the negative 2x. Minus the integral of v times u prime. Careful. 1/2 times 2 is 1. I've got a negative sign there. I'm going to put a negative in here. X e to the negative 2x. And then I'm going to factor that negative sign out to get a plus sign out here. Ignore the scribble. Are we done? No, because we still have an integral sign there. We got to do this integral. Take a look at it where I'm pointing. Looks like we need to use integration by parts again. Yes, sometimes you have to use it more than once. Try using the same kind of guidance as before. For this integral here, v prime needs to be something easy to integrate, and hopefully u prime is something whose derivative is simpler. Yes, these things work. So I have to use it again. Now I'll do that over here. Don't forget about your first term. If you forget that, you'll get the wrong answer. With the integral that I'm now going to rewrite in terms of integration by parts, I'm also going to use parentheses. It's not such a big deal because of the plus sign here, but if this were a minus sign here, the parentheses would be essential. I'm adding in parentheses u times v minus the integral of v times u prime. U times v is negative 1/2 x e to the negative 2x minus the integral of v prime is minus the integral of the product of these two things. I'll have a 1/2. The minus sign can also come in front to make this a plus sign. And the 1/2 can come out in front as well. I did a couple steps there in my head. Now we're down to an integral that's pretty easy to do. Don't forget your other terms, negative 1/2 x squared, e to the negative 2x minus 1/2 x, e to the negative 2x. And then when you integrate this one, you'll get another factor of negative 1/2. So you get minus 1/4 e to the negative 2x plus c. If I have not made a mistake, that's the final answer. But yikes, who could have ever guessed that? I don't think I could have. Well, maybe I could have because I got enough experience now. But it looks really hard to guess. That's what we were integrating. A single term with a single product. Here we have a bunch of terms, all with minus signs. Yikes. Let's check it. I will need to use the product rule both for this one and for this one. And I better be careful about all my minus signs. That looks like it could be kind of a nightmare. Take it a step at a time. Differentiate this first term, left. D right gives me an extra factor of negative 2. Derivative of negative 2x, chain rule. Lefty right plus right, e to the negative 2x. D left, the derivative of negative 1/2 x is negative x. That's the derivative of that's the first function times the derivative of the second plus the second function times the derivative of the first, if you want to think of it that way instead of left and right. Okay, minus, careful, I better use parentheses in differentiating this because I'm subtracting the whole thing. Left is 1/2 x, right, d right is this, plus right, e to the negative 2x, d left, the derivative of 1/2 x is 1/2. I'm subtracting that whole thing, put it in parentheses. Finally, differentiate this. The negative 2 is going to give you plus 1/2 e to the negative 2x. Distribute the minus sign through the parentheses. I'm not going to actually write it down. But if I do, I will get a minus 1/2 e to the negative 2x, which will ultimately cancel with this plus 1/2 e to the negative 2x. And also, if I simplify these two terms, they will cancel. Look, 2 minuses make a plus. The 2's cancel. This cancels with this. In the end, I'm only left with just this term. The negative 2 and the negative 1/2 cancel, give you 1. X squared e to the negative 2x is the simplified derivative. And that matches the original integrand. It worked when you're careful. Hang on, got 2 more examples to do in 4 minutes. But you're going to want to practice more, see more examples. They're in your book as well. What about the integral natural log of x? What? Isn't that 1 over x? No, it's not. The derivative of natural log of x is 1 over x, not its integral. To integrate natural log of x, it's best to use integration by parts. Now the advice that v prime be something easy to integrate is essential. Because if you let v prime be natural log of x and u be 1, to find v is to do the exact same problem you're trying to do. Not good. So let v prime be 1 and let u be natural log of x. V prime is easy to integrate. U prime, yeah, it is a simpler derivative. It doesn't even involve a natural log anymore. uv minus the integral of v times u prime. Multiply and subtract the integral of the product of those. U times v is x times natural log of x. Minus the integral of the product of these, those cancel to 1. Amazing. Right? X times 1 over x. Cancels to 1. We're almost done. X ln of x minus x plus c. Is that correct? Check it. Differentiation. Got a product there. We need the product rule when you check, as always. Left d right plus right d left. Subtract the derivative of x. C differentiates to 0. This is a 1. They cancel. It works. ln of x. Do I need absolute value signs? No. Why not? Because the original integrand function is only defined when x is positive, not when x is negative. So we only need the answer to be defined when x is positive. Absolute value signs don't hurt, but you don't need them. One more example. What about the integral of x squared times natural log of x? V prime needs to be something easy to integrate. Now, if V prime were natural log of x, technically, we've just integrated natural log of x. We could use this as V, but that's not so great. No, let V prime be x squared, let U be natural log of x, just like before. U prime will be 1 over x. V will be 1/3 x cubed. Answer is U times V minus the integral of V times U prime. U times V will be 1/3 x cubed natural log of x. Product of V and U prime is the product of these two things. One factor of x cancels. You get 1/3 x squared, not x cubed. That's not too bad to do. 1/3 x cubed natural log of x minus, if we do this integral, we'll get minus 1/9 x cubed plus c. Check by differentiation. Left d right plus right d left. That's the product rule. Then minus the derivative of this will be minus 1/3 x cubed. This here simplifies to 1/3. Oh, wait a minute. 1/3 x squared, sorry. This here simplifies to 1/3 x squared. They cancel, leaving you with x squared natural log of x, the original function that we integrated. It worked. Check. Okay. You need lots of practice with this stuff. Get more practice on the homework. Have a good day.